Hello everyone, welcome to this video. Today we will discuss about supervised machine learning regression technique. Topics for this today's session is introduction to regression, especially linear regression, and implementation of the linear regression. Let's start with the introduction of regression. Regression is one of the supervised machine learning technique which follows the statistical approach to find the relationship between dependent and independent variables to predict the outcome of the event. Let's take a simple equation for understanding dependent and independent variable. Y equals to max plus c, where x is independent variable and y is the dependent variable. By using regression technique, we can find the dependent variable using independent variable, non-independent variable, where m is slope and c is the regression coefficient. Some of the important regression techniques are linear regression, polynomial regression, and logistic regression. Linear regression, the regression technique which is linear in nature. For example, the equation like y equals to beta 1 plus beta 2 x2 plus beta 3 x3 plus dot, which is linear regression. Polynomial regression, the regression which is non-linear in nature. The equation like y equals to beta naught plus beta 1 x plus beta 2 x square plus dot. Logistic regression, which is an important and most special type of regression. The equation like y equals to 1 by 1 plus e to the power minus b naught plus b1 x1 plus b2 x2 plus dot. In this session, we will only discuss about the linear regression technique. Here, x is independent variable and y is dependent variable. By using the linear regression technique, we can find the y using the x. This is a simple linear regression equation like y equals to mx plus c. First, we can find the slope and regression coefficient. Then, using this equation, we can find the dependent variable by using independent variable. Here, y is continuous in nature. Generally, linear regression can be categorized into two types. One, simple linear regression, and second, multiple linear regression. Simple linear regression, the linear regression which have only one independent variable is called simple linear regression. For example, y equals to mx plus c. Here is independent variable is x only, so it is called simple linear regression. Multiple linear regression, the linear regression which have multiple independent variables is called multiple linear regression. For example, y equals to alpha naught plus alpha 1 x1 plus alpha 2 x2 plus dot plus alpha n xn. Here, independent variable is multiple. Alpha n is regression coefficient, xn is independent variables, and y is the dependent variable which is continuous in nature. Let us take a simple statistical data. Here, modal year, modal, engine size, cylinder, fuel consumption in city, fuel consumption in highway, fuel consumption comp, and CO2 emissions are the variables, where CO2 emission is dependent variable and others are the independent variable. We can find the dependent variable by using this independent variable. But in this video, we will discuss only about simple linear regression, so we can use only one independent variable for finding the dependent variable. I am using Jupyter notebook for the coding part. Let's start. Simple linear regression. Implementation of simple linear regression. First of all, let's import the required packages. Import matplotlib dot pie plot is plt. matplot is for visualization. For now pandas, import pandas spd for data analysis. Import numpy is np. Import pile spl. matplot live inline. Let's run. Alt enter. I have a dataset like this, which is fuel consumption.csv. So let's read the data frame. Data frame df equals to pd dot. For reading csv file, we have pandas library called pandas function called read underscore csv. We have fuel consumption.csv. consumption.csv. Now let's select the some features to explore. Engine size, comma cylinders, fuel consumption, dependent variable, CO2 emission. Now then visualize this parameter for finding the relationship between the dependent and independent variable. So for visualization, v is equals to cdf let's copy. First of all, we show in the histogram. So is the list plt.show. Yes, we can see the histogram of these variables. Then can also plot in the scatter form. plt.scatter cdf.fuelconsumption.com comma cdf dot CO2 emissions here we have plot the scatter diagram of fuel consumption curve versus the CO2 emissions and colors. PLT dot giving the level X level F fuel consumption comp PLT dot Y level CO2 emission then show. Sorry. Yes. Then also we can make a scatter diagram of CO2 emission versus engine size and others. Let's copy it. Fuel consumption, CO2 emissions. Now we take a engine size for scatter diagram. CTF dot engine size versus CO2 emissions and engine size. It's wrong. Yes, you can see. We can also make a diagram, scatter diagram of other parameter also. Now for making a machine learning model, first we create a train and test data set. Creating train and test data set. %, for train data and 20% for test data. Sorry. Okay, we create the train and test data. Simple regression, simple linear regression model. First of all, train the data. Train data visualization. Distribution. PLT dot scatter train dot engine dot CO2 emission. CO2 emissions. Then for X level X, engine size, level Y, we have CO2 emission. Then show the plot. As trend data distribution of engine size versus CO2 emissions. Model the data set. Data we use, let's import the sklearn library. From sklearn import linear model. Regression equals to linear model dot linear regression. Trend x equals to np dot as any array trend engine size. Similarly for y. In y we have CO2 emissions. CO2 emissions. Then feed the trend data. Regression dot feed trend x and trend y. Now regression dot curve. And intercept. Intercept. Okay. Sorry, here is mistake. Okay, we can find out the coefficient and intercept of the equation. Here coefficient is 39.56 and intercept is 124.002. Then here we already find out the m and c. Then we have x. Then we can calculate the value of dependent variable y. Let's start. plt dot scatter friend dot engine size CO2 emissions. Plot trend x, regression coefficient, x plus 10x and regression intercept. For evaluation, we require test data. Test CO2 emissions. Then predict print the mean absolute error.
Here mean absolute error is 22.29, residual sum of square is 837.93, and R2 square is 0.71.